We are taking R.D. Sharma solution, class 12, chapter 18, Maxima and Minima, exercises 18.3. fx is equal to x into e raised to the power x. Now we have this fx and this x into e to the power x. The first step for finding the local minima and maxima with the double derivative. So we have to differentiate it twice. The first differentiation is mandatory in both the cases if you are using the first derivative or second derivative. So when we take the derivation or derive it, we'll use these product rule. So I'm using the product rule, and finally we got e raised x plus 1. Once we get this expression, the second step, this is the first step. The second step is to put this as a 0. That is e raised x plus 1 is equal to 0. So e raised x can be 0 or x plus 1 can be 0. When x plus 1 is 0, that means x is equal to -1, and e raised x cannot be equal to 0. Now you tell me, what is the value of e? E is a constant. It's 2.714 something. Any value, any number in the real set, if you place it, it's not going to give you 0 in any case. We are only left with x is equal to -1 now. This x is equal to -1 is the critical point, and this point you are going to get local minima or maxima. So the third step is double differentiation. So what do we got? E raised x plus 1 was the first derivative. We are going to get the second derivative. Again, this derivative is quite clear to you. Just use the product rule, f double dash x. So this x is to be replaced by -1. We are going to check the sign of double derivative at the critical point, which is -1. We get e raised -1, x plus 1, so I am replacing it by -1. -1 plus 1 is of course 0. This one is eliminated. We get e raised -1, that is 1 by e, it is a constant. We are only interested in the sign, and this sign is positive. You are going to get the value which is greater than 0. When you have greater than 0, that indicates that this point x is equal to -1 is the point of local minimum or maxima. Minimum greater than 0, minimum less than 0, maximum. It's inverted in this case. Next one is fourth step, and the fourth step is the value of the function at x equals to -1, which is the critical point. So we got that x equals to -1 will be local minima, and what will be the value of local minima? It's going to be putting the x equals to -1 here. Now let me draw and show you that we have this x equals to -1. It will not be here. It will be on the left hand side. When we have on the left hand side this x equals to -1, this is x, and you are going to get y out of it. That y value will be found by putting x equals to -1 in the original equation, which is x e raised x. Y is equal to x e raised x. Now replace this x by -1. You get -1 into e raised -1, that is -1 by e. This is the final value. This is the whole solution in front of you. You can take it as a reference. Try it yourself. Any problem, just refer it. All these things you have to write by yourself. This is very important. Solving is more important, but most important is writing what you are actually explaining or doing. This question, x is greater than 0. We have already done a question like this. We have the function. We have to take the derivative. First derivative, and you already know the derivative, half minus 2 by x square. Next one is to place this as 0 or equate it to 0. 1 by 2 minus 2 by x square is equal to 0. So you'll get x square minus 4 by 2x square. I've just taken the LCM. When you take the LCM, this x square will be equal to 4. When you have x square equals to 4, that is plus minus 2, because under root 4 and this square can be negative or positive. It is going to get positive only. That's why plus minus both has to be taken. Now we have critical points, x equals to 2, x equals to -2. Now I'm doing something. You have to find that what wrong I am doing. I have to find the local minima or local maxima at x equals to 2 as well as x equals to -2. Next one is the double difference, and this 1 by 2 minus 2 by x square, 1 by 2 will get eliminated. Minus 2 by x square you can take in the numerator. It will be x cubed, so 3 will come in front, and it is going to be, the 2 will come in front, and this 2 minus 2 minus 1 will be x raised minus 3, and you can just take this in the denominator. Finally, you will get this 4 by x cube because it was already negative 2 by x square. When you have 4 by x cube, this is 2 and minus 2 you are going to check. I am still wanting you to check what wrong I am doing. Again, 4 by x cube, first put 2 cube and then replace x by negative 2 in order to get both the value. 4 by 2 cube, don't worry about the value, it can come any value, but you are worried about the sign. F double dash 2 will give you positive value, F double dash minus 2 will give you negative value. Positive is local minima, negative is local maxima. But the problem here is, in the question, it is already given x is greater than 0. When x is greater than 0, that means it's not taking x equals to negative 2. You need to stop at x equals to negative 2 when you start working with it. Because in question, it's already being said x can only be greater than 0, which indicates you can only take x equals to 2. You have to ignore x equals to negative 2. The value will be half for f double dash 2. That indicates it's a local minima, because positive means minima. See, I also get confused in minima and maxima because this is inverted. For positive, it's minima. For negative, it's maxima. The value of the function at 2 will be 2 by 2 plus 2 by 2. That is going to be 2. So local minima is by 2, and at 2, you get the value. This is the whole solution in front of you, and we have just ignored x equals to negative 2 because x is greater than 0, which is already given in this question. And all these things like f dash x equals to 0, then f double dash x, placing the value of 2, and then finding out greater than 0, less than 0. Next one is x is greater than or equal to negative 2. Let us see what value we get as the critical points. If they are not following this x greater than or equal to minus 2, we will change it or will ignore certain things. First step is simply the differentiation f dash x, and you can just use the product rule for simple first derivative. Let me apply the product rule. That is, you have to keep the first one, differentiate the second one, then put a plus sign, then do the otherwise. That is, you have to put the second one untouched and the first one has to be differentiated. Okay, now what do you get? This differentiation is quite known to you now. I'm just doing it for the sake of completion, just to know that what you get is what I also show you, while if you're doing it commonly or with me only. So this is the differentiation, and I hope you are quite well versed with it. There will be certain negatives and positive going to appear, but our idea and our key is to find the local minima or local maxima. For that, we have to put this f dash x as a 0. Once we place this f dash x as 0, you can take certain thing common because you have this, or rather you can just use this expression and keep one term on left and the other term on right. This right and left, you will get this x plus 2 1 by 3, x plus 2 negative 2 by 3. You can take this on the left hand side, and this is going to get added, because when this x plus 2 goes on the left, it will be x plus 2 raised to the power 2 by 3. And you know, when the base is same, the power gets added. 1 by 3 plus 2 by 3 is just 1. So x plus 2 you get here. On the right, it is 1 by 3 x plus 1. Now just multiply this 3 with x plus 2. So you have this 1 by 3 x plus 2. Multiply both sides by 3. This is 3x plus 6. On one side, let us multiply negative also. On the right, it's x plus 1. And from here, we will get 1x value, and that will indicate that this is the point of possibility of local minima or local maxima. What it will be is still unaware. We get x equals to negative 7 by 4. Now imagine that finding out the local minima and maxima when you have negative 7 by 4 and not using the double derivative. In the previous exercise, we have seen that we have to go on the left and right certain values which goes on left and right of negative 7 by 4 and then find whether the sign is positive or negative. So it will become quite cumbersome in these kind of values. So the best way is to take the double differentiation. Now I am double differentiating it. I am going to write the actual value, because double differentiation is going to take certain time here, and I know that your time is very precious. So let me write the second derivation, and second derivation, because it will take some time to solve all this or to find out the second derivation. I am placing this second derivation in front of you. And now the next step is we are only left with x equals to negative 7 by 4. Now, did you check this negative 7 by 4 is actually following x greater than equal to minus 2? Now, you just have to take a guess. I mean, when you place negative 7 by 4 in x, in f double dash negative 7 by 4, you are going to get greater than 0 or less than 0. Let me tell you, you are going to get greater than 0. And this value, when you place this, finally you are going to get x replaced by negative 7 by 4. And there will be certain values, or there will be certain computation which I am showing you, and I hope that you will also be able to complete. But all in all, final value will be positive, because 1 by 4, negative 2 by 3, 1 by 4, negative 5 by 2, they are same. They will never be negative. So we get, for greater than 0, it will be local minimum. Minimum, less means less than 0 means maximum. Greater than 0 means local minimum. Next step is to find out the value of the function at this x is equal to negative 7 by 4. Now just replace this negative 7 by 4 in the original equation, which is fx. fx, that is x plus 1 and x plus 2 raised 1 by 3. Now replace x by negative 7 by 4. That is the same thing I am doing and trying to find out the final value. This final value is this. You can refer what we just explained and see and find out, and write also. All these sentences are to be made by you, are to be written by you, because the steps already you understand. We are on the 7th question right now. All the steps you are aware. Only the computation part, I leave it for you. But the final thing is, this is the whole solution. You can refer to it. And negative 7 by 4 is actually greater than equal to minus 2. How do you find it or conclude it? Because we have x equals to or greater than negative 2. Everything on the right is the value which is acceptable or admissible. But we got x is equal to negative 7 by 4. This negative 7 by 4 is actually, let me just divide and show you. It will come as this 4, 1 is 4, 3, and 7 4 is 28. Around negative 1.7 will come, and this negative 1.7 lies between, which is nearer to negative 2, but still it's above negative 2. So it's fair that we have taken this negative 7 by 4 and found out the value. fx is equal to x under root 32 minus x square minus 5 to 5. We have the interval being given x between negative 5 and 5. We will follow the same step that we have been following right now. First step will be the differentiation, f dash x. Differentiation, you can just use the product rule. Because we have already done differentiation, I'm going to write the differentiation, and I hope that this will be acceptable to you, because our idea is to find the local maxima and local minima. First, take the first one, differentiate the second one, then take a plus sign, put a plus sign, then do the inverse, that is, keep the second value, differentiate the first value. So this is what I'm doing right now. This is f dash x. The second step is to equate it is equal to 0. F dash x equals to 0. So I'm just making steps easier for me and just replacing this equals to 0 as equals to, because we have a negative sign in between. So when we put equals to 0, these both will be equated on left and right. Now you have under root 32 minus x square on the denominator and numerator of left hand side and right hand side. When they multiply, you get 2x square equals to 32. This x square will be 16, x will be plus minus 4. Now this plus and minus 4 should be in between the interval being provided by negative 5 and 5. You can just check it, and I can assure you that these two both values are admissible, or you can say we can take both the values, or we have to take both the values in order to get the local minima and local maxima. The third step will be to find out the differentiation of the differentiation. That is the second derivative of the original function. First derivative we have already computed. The second derivative is only for the sign, to find out the local maxima or local minima exist or not and what are the values of the negative x. I'm just differentiating it. I'm just saying that this differentiation I'm going to write direct. This can be done because it will take certain time, and I have explained you that this is the time of short. People don't need all the explanation, they just need a hint, logic. So this is the logic. The logic is differentiation is up to you, and this is the whole differentiation, second differentiation which I'm writing right now. You can just verify it. This is the second differentiation, and now we have to check for 4 and negative 4. 4 and negative 4, f double dash 4 and f double dash negative 4. Just try to find out what will be the sign. Please remember, for double differentiation, we are not interested in the value. We have to do nothing with the value. We have to do with the sign. Sign is negative because f double dash 4 will come as negative 3. Negative means local maxima. Positive, that is 3, means local minima. Negative, maxima. Positive, minima. And when you get this, now you need to find out the value of the function at this negative 3 and 3. f4. f double dash 4 no. f dash 4 no. f4. This 4 and negative 4 has to go in the original equation. And since you see the square inside will be positive and negative in any case because it is being squared. And 4 and negative 4 outside, so there is only the difference of sign of f4 and f negative 4. f4 will give you 16, f negative 4 will give you negative 16. And up till now you have known that these are the value of the function at local maxima and local minima. First one is local maxima, the value is 16, local minima value is negative 16. So this is the reference of the solution I just explained. Differentiation is, I always say that this has already been completed, and differentiation is your responsibility. x cube minus 2ax square plus a square x. A is greater than 0. X belongs to real number. First step is f dash x. Differentiation of this function. It's 3x square minus, I'm differentiating it, minus 4ax plus a square. The first step is already done. The second step is to equate this f dash x to 0. When you place it as 0, it will be 3x square. You can make the factors out of it. And when we make the factor, then we get the critical point. This equating to 0 is only for the critical points where it can be found that local maxima exist or local minima exist. I am just making the factors. You can write this as negative 4ax as minus 3ax minus ax, and finally just put these two as 0 because any of these factors can be 0. From first we got a by 3, the second one we got x equals to a. Next step will be the double difference. The differentiation has already been done. The second one is the double differentiation, f double dash. We get 6x minus 4a. This is the only thing which we are going to. Now place a by 3 one. The second time place a, and then just worry about the sign. What is the sign you are going to get? Because this sign will tell you whether it is the local minima or local maxima. F double dash a by 3. Sometimes we also call it as f double prime, but you understand that when I say prime, it's derivative, double prime, it's double derivative. So now the value of the function we are not interested in. We are more interested in negative of 2a. Negative means you are going to get the negative value, which is indicating that this is the local maxima. 6a minus 4a is 2a. When you have 2a, that indicates that you are going to get the local minima. Negative, again and again I am saying, because the whole theory of this exercise is the value, not the value of f double dash, but the sign. Negative gives you local maxima, positive gives you local minima. The only thing which is left is to find out the value of the function at these two values, which is a by 3 and a, which also is considered as the critical value. Original function you have to use. Please remember f prime, f double prime, leave it now. We have to go back again to the original equation and replace x by a by 3 and a. And what are the values you are going to get? I hope that you are quite aware now that what we have been doing. It's a cube minus, I'm placing a for the first time. A cube minus 2a cube plus a cube is 0. When we place a by 3, the value is going to come as 4a cube by 27. So these are the values. This is the reference for you, because all those things which you are going to write is being shown here. This will do next. Thank you.